Yeah, good evening, everyone. So, Chanak, let's start off. Hope everyone has tried the homework problems, and I'm sure some of you forgot even there are two homework problems. So, how many of you tried these homework problems? Hands up. 1, 2, 3, 4. So, there are a few hands up. Okay. That is the reason I kept it on the screen. I know the moment you see, you'll realize, oh shit, there is a homework problem we forgot. So, put your hands down. Let's see how to do this thing. Everyone must be in the festival mood. पता है स्कूल में used to get 5 days holidays ना. You don't get anything here. You have to sacrifice holidays in 11th and 12th so that you can get more holidays in IIT. You get a lot of holidays in IIT. So how do we do this? Anyone got an answer for this thing? Others need to keep your cams on. I hope everyone has given the test. I'll be putting the results and the thing. If you find any corrections in the paper, you can message me in WhatsApp. I'll do the corrections and I'll post the results by tomorrow morning. So Friday, you can ask the doubts of the paper. So we'll keep it that way. Every Friday, we can discuss the paper cut doubts. So, and the results I'll put it on Wednesday or Thursday. How is the paper? Easy? Next paper is advanced, huh? It'll be fun. When I say that, people say, sir, it is fun for you. Like, let's see how to do this. Anyone got an answer for this? Ronak, Udian, Kamson, Mehan. Yeah, there's still 4 people missing. How do we do this? Find omega if the rod is about to slip. Now, there are 2 things here. At a distance x from the center, take a small piece dx. Now, if I take this small piece dx, let's see what are the forces acting on this. Tension, T plus dt. So this is the tension on the right hand side. The centrifugal force, dm omega square x, and the friction, df. I hope everyone got the FPD part. So there are total 4 forces acting on the small piece dx. And for this small piece, dm will be mass by the length of the rod is r by 2, mass by total length into dx, which is 2m dx by r. Please check everyone. This is the starting point. You should know how to draw an FPD. And we have done something like this, that was this problem, if you remember. So T plus dt, and dm omega square x. And the only additional thing is there's the friction now. Please check this FBD. Ritu comes on, Venkatesh comes on. There's no rope. How can there be tension? God, what is this thing then? This is a rod, right? Rods have tension, isn't it? Clear, na? Oh, please check everyone with FBD. If you got the FBD, right, that is like half job done. Clear? Then, how do you know you have to integrate? The first thing when you have seen this itself should have given you a big clue that there is integration involved. Friction coefficient is not constant. So now on this piece, so I can write like this thing. So if you take this full rod, there are frictions here. So df, 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 df. These are all frictions. And these are all centrifugal forces. dm omega square x, dm omega square x, dm omega square x, dm omega square x. Can I write like this? The total centrifugal force should be equal to total friction. If I take the full rod, if I take the FBD of the full rod, This is FBD of dx piece. So integral df will be integral dm omega square x. Please check this thing. And what is the friction here? And df will be mu dm g. Mu is mu naught x square and dm is 2m by r dx into g. What is dm omega square? That will be 2m by r dx omega square x. So you just have to substitute everything here. So this guy would be mu naught 2m by r g integral x square dx. This guy would be 2m omega square by r integral x dx. And x ka values will go from, the rod starts from r by 2 and ends at r. So r by 2 to r and r by 2 to r. Please check this thing. I'll show it in the next page. So there are two different FBDs here. This will give you tension. I'll show you that later on. But first we are doing the first part. Find omega so that the rod is about to slip. Please look at the steps what I did. So on the entire rod, the total friction acting on the rod should be equal to the total centrifugal forces pulling the rod. Anyone not clear with the steps? Everyone? Udayan, clear with this? Mehan? Venkatesh? Vartika? Sure with the steps? Aryan? Abhinav?
Yeah.
Then integrate this thing. Mu naught 2 mg by r x square dx will be x cube by 3. Limits will go from r by 2 to r, and this side would be 2m omega square by r x square by 2. Limits will go from r to r by 2. Finish it off. You're done. Actually, this m is gone. This is 2 gone, m gone, r gone, 2 gone, r gone. This would be mu naught g by 3. This would be r cube minus r cube by 8. That would be omega square by 2 r square minus r square by 4. And solve this. You end up with omega will come from here. I'll leave the working to you. This thing you can do from here. कर लेते हैं तो इतना depth of mu g by 24. This would be 7r cube. Is omega square by 8, 3r square. 8's are, 3's are. So omega would be mu naught 7 mu naught g r phi 9 ka root. That's your omega, everyone. Anyone got this? Who got this? Please check the steps. If you got till here, question ho gaya actually. Just calculus after this. Calculations are fine, but the main thing is this. At least the omega ka part you should have got it, right? That is the reason I gave you time, right? God, you should have tried this. Advanced में question जैसा ही आता है. It's really not really, out of your reach. Maybe you should have spent at least, like, could have taken 15, 20, half an hour also on this thing when I said some of the homework problem. Again, not on the same day. Maybe today you tried this for 6-7 minutes. Tomorrow you should have tried for another 4-5 minutes. Before the class, you should have tried for another 4-5 minutes. If you did it in multiple times, you would have got this. And you could have taken inspiration from this problem. How to take elements and everything. See, tough problems, you can spend some time. Make sure to remember this thing. Should try this thing. If you don't try, you won't learn how to handle this tough questions. Advanced papers will go tough for you guys. Clear? Any doubts on this part? वो भी है DM तो you have to write carefully. All clear, Anika? Got this now? Palak, Ritu, show the steps. Now, how to get the tension as function of x from here? This guy. So on that small piece dx here, we have forces T plus dt. Remember, we always take the tension to be increasing. T backward. The centrifugal force dm omega square x and the friction backward. And remember, the free ends will have zero tension. So if you write this thing, dt plus dm omega square x should be equal to df. So dt will be df, which is mu naught x square dm g minus dm omega square x. Integrate dt from 0 to t. This guy would be mu naught x square 2m by r dx g integral. This will go from r by 2 to x minus 2m by r omega square x dx. To m mu naught by r g x cube by 3 minus r by 2 whole cube by 3 minus 2m omega square r by 2 x square minus r square by 4. That's your tension as function of x. You have to take that omega from previous one and substitute here and solve it. I will leave it to you. That is fine. Check this out. This is how you get tension in the rod as function of x. Remember this thing, whenever they ask you find the tension in the middle of the rod, you have to take a small piece dx. Then you have to say left side t and right side t plus dt. If you don't do this thing, now dt aayega nahi. You won't be able to get t out of the function. So the dt is the small increase in tension for that small dx. And remember, free ends have zero tension. So in our case, that rod which is there, x is equal to r by 2, x is equal to r, tension is zero on both the corners. Yeah, I could have asked you more actually. I can even ask you find the maximum tension in the rod. Find the point with the maximum tension. That would be a third question. If you see tension is 0 and 0 means it is increasing and decreasing somewhere. That would be another question. Find the point on the rod where tension is maximum. This level of problems, you should get used to it. Now, today after the class gets over, take out this. Now you have seen the full thing. Trust me, do it today only. Take a rough paper and try this on your own. Trust me, you'll still get stuck. Why? You didn't do anything. I did everything for you guys. You were just watching this. Try this today evening, maybe after a dinner or something. Na? Just 10 minutes, take out a paper and try to do this whole thing. You will get stuck. Struggle a bit. 5 minutes, 10 minutes, struggle a bit. You will get it. If you don't get it, then look at the solution. Now you will get it. That is how you learn. If you just think like, हाँ sir कर लिया, मैंने देख लिया and done, तो trust me, this whole thing will vaporize. Because this concept what I'm teaching now, it won't stop here. You will again encounter this question in other chapters. For example, I'll just show you. These are nothing integrations actually. When we look at now, when we deal with later on with your seniors, this thing. Here. Same question, similar question. We have a test tube filled with water and rotating with omega. Find the pressure inside the liquid. Idea was the same. You're getting it? It just doesn't stop at one place. This kind of questions will keep coming multiple places. Integrations, limits. You need to get used to it. And these ideas that suddenly won't come on that day. You have to develop them day by day. So next time when I give you a homework problem, understand there's a reason. See how long it took me to teach you only. It took me almost like 8 to 10 minutes to teach you. So when you're trying at home, you'll need at least 20-25 minutes. That is the reason I give you to do this at home. Now, if you're not doing it, then you're all losing an opportunity to figure it out. Please take the steps. This would be a homework question for you. Now you try. I can ask you plot tension versus X graph. I can ask you multiple things. Neil, you have to be on time for the class. This is not a regular class where you can silently sneak in from the back bench and sit inside. We used to do that. Doesn't work here. All clear with this? Any doubts on this, please ask. Great. What about this guy? Didn't try, I'm sure. Take 2 minutes. Give it a try. I hope the question was clear. We have a disk with a groove inside and you have to block at distance of r by 2. This thing starts rotating with omega and this block just comes out of this groove and flies off. Find the speed when it comes out. This is an easy one. Give it a try. What happened, Neil? You were busy today? Something happened? Overslept? Puja? You're eating laddus. If you say you're eating laddus, I'm totally fine with that. Okay. Okay. Always leave a message, but if there is an issue, right? Leave a message in WhatsApp. Sir, so and so is happening. Then I'll understand there's a problem. But if you come late and then you message me, I will think you're giving an excuse. I know physics people are very suspicious people. Don't make me an evil teacher yet. Your seniors notification is out. Jan 24th is their mains exam. Luckily, it was delayed by 2 weeks this time. But this will create another problem. Board starts from Feb 20th. They don't have enough time for board preparation now. Any answers? How will this thing go? As this thing comes out now, if you observe, this will actually spiral out. It keeps coming out, it is going rotating and it spirals off. Try. I'll give you a minute more. Anyone not clear with the question, please ask me. Everyone should try. Venkatesh, do adjust your cam. I can't see you. Everyone, please do adjust your cams. Make sure every class I can see your face completely. This is something I keep telling you every class. Looks like you guys are ignoring me. Don't let me take revenge. I'll keep the tough paper next time. What else can I do? I'm just an innocent physics teacher. Try. Today I learned a new integration. E power minus 2x dx का integration था. This great guy. This what it did. I was like, what did you do? He said, sir, e power minus 2 is constant. It came out, so x बच जाएगा अंदर. So integral x dx. I was like, gods, what maths are you guys learning? Like, yeah, people are not. So who is dragging this block out of the groove? The centrifugal force, right? So question, right, is easy only, but there's a catch. Let's see. So let's say the ball is somewhere here at a distance x. The force acting on this will be m omega square x and acceleration. So m omega square x is equal to ma. This and this will cancel. You end up with a is equal to omega square x. Now be careful. This is the radial acceleration, meaning acceleration away from the center basically. So when I integrate this, I end up with v dv by dx is equal to omega square x. Omega square x dx integral. This will be from 0 to v, and this will be from r by 2 to r. V square by 2 omega square by 2. That would be r square minus r square by 4. You end up with root 3 by 2 r omega. This is not the answer. This is the radial velocity. Meaning this is the velocity with which it is being pushed away from here. So when this guy is coming out, actually there are two velocities. So this ball which is here, so when it flies off, so this is your radial velocity. And also remember it is going in a circle. So this is a v tangential velocity. You're getting it? Because it is going in a circle, there's a tangential velocity plus also a radial velocity. You have velocity along the groove, plus you also have a tangential velocity. So you can try this thing. You can actually, put a duster or something. We should do this in school. You ever did this thing? Kept a duster on top of the fan. And then you sit silently. Someone comes and switches on the fan. The duster flies off. I think all your schools must be air conditioned. So you never got to learn this kind of stuff. Never seen that? If you keep a duster on top of it and leave it, when you switch on the fan will rotate, the duster will fly and hit someone. So the safest place to sit under the fan. So we used to put duster, chalk pieces, everything on top of the fan and leave it silently. Someone comes and switches it on. I never used to do such kind of evil things. I just used to take a chalk piece, make it into a powder, and keep it on top of the fan. So when you switch it on, the people under the fan used to get all the chalk piece powder. So this is V tangential. So you can try this thing. If you keep something, forget about the fan. See, you can do this on your palm also. If you keep something on your palm and if you try to rotate it, you'll observe this thing just doesn't come out straight. It actually goes at an angle. It doesn't fly straight outside. So this would be your final speed here. So the final speed will be root over v radial square plus v tangential square. This is the thing most people forget. They find only this speed and they think ho gaya. What they forget is this will also have a tangential velocity. So this guy would be v tangential is r omega. V radial is root 3 by 2 r omega. If you square them and add them, 3 by 4 plus 1, 7 by 4, root 7 by 2 r omega. Check, that's your answer. And this thing comes out at an angle. It's a spiral. Clear, everyone? Any doubts on this? Please ask me. Any step you're not clear. So the centrifugal force is actually dragging you outside. So that gives you velocity along the groove, and there'll be a tangential velocity. Clear? Turn in the page. Let's see something more simpler. So we have a person is sitting in a giant wheel. So this is your giant wheel. I'm sure you must have gone into this thing. So we have a person here who is sitting at this position. A person is in a rotating giant wheel. Find the direction of the force on the man, on the person due to the person exerted by the seat. So options would be examined like this thing: A, B, C, D. ऐसा four options होगा. So you're sitting in a giant wheel ka seat, and this guy is just going in a circle. So the seat is exerting force on you in which direction? A, B, C, D. These are the options. Trying mostly a theoretical question, easy one. Think I'll give you a minute. I hope the question is clear. C, D, D. Okay. Okay. Yasha says B. You have B, C, D. सब हो गया. कोई A भी बोल दो कोई. ये बोल दिया कोई भी. Lot of C and Ds. You have two Bs. There are 5 to 6 Cs and no. Oh. See, answer is B. What is happening here? You guys are goofing up something. If you draw FBD of the man, question क्या पूछ रहा था? Force exerted by the seat on the person. So what are the forces? The seat is doing two things. The seat is pushing this way. The seat is also pushing you from down, isn't it? For example, you're sitting in the chair, right? Chair is pushing you up, and your backrest जो है, that is also pushing you forward, isn't it? So the seat is actually giving two forces to balance what? This is your centrifugal force. This is your mg. So on the man, the seat ka force will be like this. The resultant would be like this. You're getting it? So this is the resultant force of the seat. Clear? So right now you're sitting in your chair. The bottom part is pushing you up. The back part is pushing you forward. So if I ask you what is the force exerted by the chair on you, what is it? It is front also, it is up also, no? So resultant will be at an angle B, isn't it? Easy? Got this? The answer is B for that. Be careful, it is not D. Next one. An aeroplane is going in a horizontal circle with speed u. The F is the force due to the engine. So the question is, which of the following is the correct FBD? Option should be something like this. Hmm. So basically, this aeroplane is going in a circle. Plane is going in horizontal circle. Plane is just flying in a horizontal circle. Never did that. When you come to Mumbai airport, when it has rushed, sometimes the plane is just going circling around the airport. Which of the following is the correct FBD? Try. These things are simple. These are the kind of questions you'll get in bits or mains. Meaning mains out of 25, you'll find at least 8 to 9 questions of this level. Now, one important thing I'll tell you. Whenever they ask you to draw FBD, nothing is mentioned, always choosing the ground frame. Nothing is mentioned, always take ground frame. If nothing is mentioned, always choose ground frame. So tell me one thing, in ground frame, will you ever get centrifugal force? No. So what are the forces acting on the plane? B is the answer. So if you look at the plane here, the forces will be the plane ka component now. This is F. If I take this guy as some theta, F cos theta, F sin theta, the plane ka engine has to do two things. One component will balance weight and one component will provide the required centripetal acceleration. So this balances weight. This F sin theta provides centripetal acceleration, or else it will not go in a circle. So engine ka force should be at an angle. Getting this thing? Because it is a ground frames. If this is the diagram in case of a reference frame, if the observer is standing on the plane, this is the answer. So B is the answer in the ground frame. C is wrong. There is no one to provide the centripetal force. D is definitely wrong. You can't have centrifugal force toward the center in this case. Most people get confused between A and B only. Remember, you are not supposed to draw centrifugal force in the ground frame. Because centrifugal force is pseudo force. Ground frame acceleration is 0. There is no pseudo force. That is the first thing. The moment you see the word mu square by r, the diagram is wrong. Clear with this, everyone? Please check. Clear? Next one. Banking of roads. Any doubts on this? Abhinav, clear, na? Vartika?
Yeah.
Anika, clear? Venkatesh? Neil? Clear? Neil? Got this? Arjun?
Yes, sir.
Next. Banking of roads. What is this banking of roads? I'm sure you must have seen something like this. When I used to go to school now, I used to go on a cycle. It used to be almost 4 kilometers. So the National Highway 5 used to pass through the center of the city that time, Visakhapatnam. Right? So at one part of the road, the road used to be like little bent like this. You know what I used to think? Whenever rain falls, water will go away. Easily road is bent at an angle. And that is, you create your own logics and stuff. So I always used to think the roads are curved, or bent because of rainwater. So, but that's not the reason. So let's see, what is this exactly? Curved roads. So if you're a civil engineer, right, it is important that you construct a road on which, you can control the speed. You can tell what speed you can go. You don't want a road, where it is not in your control. I constructed an angle with the horizontal. This angle is called banking angle. Let's see what is the issue here. Case 1, let's take a rough horizontal curved road. If you just construct a road without any banking, top view, so let's say this guy is going with V. Now we know if you're going in a circle, there should be a force acting on it. Friction. So this will provide the required centripetal acceleration. So we get F is equal to mass into centripetal acceleration. But I know friction is always less than equal to mu mg. So a centripetal acceleration is v square by r is less than equal to mu g. So v is less than equal to mu g r. Means if the vehicle goes faster than this, right, it will slip. So up to this speed, there is no skidding. Now the problem here is that speed which we got completely depends on mu. For example, think about it. Morning, you're going on a road and morning it is very sunny and all. So you're going at 50 kilometers per hour. Evening while coming, it started raining. The road became a little slippery. So suddenly mu ka value will change. You start skating on the road. You buy a new vehicle, tire has good grips. After using the vehicle for 1 year, the tires have become little smooth. Vehicle slips. You're getting the problem? you are relying on something like mu, which depends on the condition of the road and the vehicle. If you don't bank the roads properly, we will see later on. This happened in Mumbai also recently, 3-4 months back. These people opened up a flyover. In the flyover, there are turns. Literally, every two-wheeler which is going is falling down. First day they opened the flyover, within first 1 hour, 20 accidents. People were just going and skidding and falling down. Right. So the road became smooth for some reason there, and it was not banked properly. And then they had to do some repairs. They had did something. I don't know whether they opened it or not. They had to close down on the same day. So the minister or someone came, opened it, big there. People went, fell down. They closed the bridge. Yeah. So this is there. So mu depends on the condition of the vehicle on the road. So basically, you don't have any control over this. So if you're a civil engineer and if you build a road like this, it's pretty bad. You created a road where you have no control over it. When you just think about it, if you buy a new vehicle, it won't skid. After 6 months, it will start skidding. Right? What the hell did you do? So constructing roads, which are flat and curvy are a pretty bad idea. So how do we do this? So we construct roads at an angle. So let's take a case 2, which is smooth banked road. So we will take a smooth one. Later on, we'll take a rough one also. Means you construct the road like this. How does this look? You can see this more clearly, when you're looking at this F1 race cars or NASCAR. This is how the roads are. Can you see how much it is banked here? It's almost 31 degrees banking. These things are going quite fast, so you need a very, a very long, very high angle here. Indian roads normally we don't go at this speed, so like what? Even vehicles don't move only most of the time. So the banked roads will have a banking angle of something like 8 to 9 degrees. Mumbai is still fine. You should go to Bangalore and see. You'll try. Hopeless roads are. I mean, traffic is too bad. I was there in Bangalore for a few months, long back. I still remember. I was in a car. I was stuck. Meaning, I took a class somewhere in a place called Hosur. 4 teachers. We went there in the morning. We finished our classes by 2 o'clock and we are coming back. 40 kilometers ka journey. First 30 kilometers was a super highway. We came off. 30 kilometers we covered in 30 minutes. Last 10 kilometers was in the city. The vehicle stopped there at 4 o'clock. The other 3 colleagues who were there with me, they got down. And I was like, why are you guys getting down? Vehicle will go come. I said, Kuch nahi hoga. You also come out with us. It was my first day. These people went outside, they started eating pani puri. One guy went even for shopping also. He brought some shoes. He came back after 20 minutes. Vehicle went from here to here. When the vehicle was here, it went here. They came walking aram se. They kept all the luggage there. They went somewhere else to roam. That was hopeless. And finally, we like literally, I think they walked almost 1.5 kilometer like that. Then the traffic got cleared a bit. They said that section of the road, every time they get stuck for almost 45 minutes. The last 10 kilometers, it took us 2 hours to cover. So recently, one of my friends is there. I asked him, did anything change? He said, nothing changed. Nothing changed. Mumbai to Bangalore, the plane ticket is around 1800, the cheapest. Getting it? From airport to his house, the taxi cab takes 2200. He says like, but it is, the plane ticket is cheaper. So what they do, right, is Bangalore people mostly, when they come to, at least my friends or someone, they always travel in the midnight, 2 o'clock, 3 o'clock flights they take, so that there is no traffic. If you go during this time, so you're gone. You can forget about the flight. Anyway, so this is how we bank the roads. So how does this help?
Sir, can you
Excited
go
in
back for a minute?
this one.
TVS.
Why, I was thinking, what did you like in this right now?
Thank you.
So this is theta here. So if you look at the FBD, this is going in a circle of some radius. What are the forces on this? Normal reaction, mg. Since you're going in a circle, there is a centripetal acceleration. So this is the normal reaction. This is theta. This is 90 minus theta. So components will be n cos 90 minus theta, so n sin theta, n cos theta, mg, and centripetal acceleration. So here n sin theta is providing the centripetal action. Did you see? Centripetal action depends on n sin theta, and n cos theta will be mg. If you divide them, you end up with tan theta is equal to AC by G, and AC is V square by RG. So we got V is equal to root over RG tan theta, independent of mu, obviously. Meaning, if you see this thing, right, V is RG tan theta, it does not depend whether you take a cycle, you take a car, you take a lorry, whether it is raining, it is not raining, the tires are smooth, the tires are not smooth, it doesn't matter. This velocity depends only on the radius of curvature, gravity, and theta. If you go with this speed, the vehicle will not slip. So this guy is independent of mu. Now, if you have friction, it's a bonus. The friction becomes a secondary safety factor. This is independent of mu. This speed is called banking speed. And this angle is your banking angle. So there, this is a road where you have a complete control over it. And if you have friction here, friction becomes a secondary support. If you go faster than this, friction will come and balance that extra thing. That is the next case. That is a final case actually. What happens if you have friction and also banked? So unlike the first case where you're completely depending on friction, your friction becomes secondary. If you try to exceed the speed, the friction will come and give you that additional force required. So there, this is how you have a control over the speed of the road.
Banking of roads 01. When a car takes a turn, each curvilinear section of the turn can be approximated.
There, this is what I was saying. If you see this road now, it is flat, horizontal, curved road. This is not banked. So if you make a road like this,
to be an arc of a circle with a certain radius. A centripetal force must act towards the center of the arc to enable the vehicle to move along it. This centripetal force is provided by the static friction of the surface the car is moving on.
the frictions on the four wheels is actually making you go in a circle.
Normal force N balances the weight of the car mg. If the coefficient of static friction is mu, the maximum frictional force which can act towards the center of the arc is mu mg. While making E square,
So if you write those equations, we get velocity.
V should be less than or equal to the limiting value root over mu rg. Moves with a velocity greater than the limiting value, it skids away from the center. Banking.
This is what I was saying. If it starts raining in the evening, the road becomes slippery.
We cannot always rely on friction as it depends on external factors such as rain or frost, which significantly decreases the value of static friction. To avoid skidding of vehicles at turns, the outer edge of the road is raised up
This is
which
how,
is
this is
called
like too much it
angle
is, but
Suppose surface of the road at a turn makes an angle theta or section here. Therefore, arc
this is the
issue
calculations
and
I was
radius
showing you.
of curvature would ensure speed of a turn.
So here, there.
Rate
It
of
doesn't
speed
matter what
of a
vehicle you
curve
take.
does not depend on the mass of the object. Summary. The maximum speed with which a vehicle can
There. So that's what happens if you don't bang the roads. You start skidding. So he was saying, I said rains. If you see abroad, so they will have this frost also forms on the road. Optimal speed is a bank speed, yeah. Optimal speed is a bank speed. So normally when they decide this, the speed limits or something, that is one of the things they take care. Clear? Now what happens if you have friction also? So rough banked roads. So what if it is banked and plus you also have friction? Case 3, this is there for HSC derivation at 12th standard. Mein. Now, let's say you're going pretty fast. So maximum speed. If vehicle goes at a maximum speed, the vehicle will try to slip outside. So if you try to draw the FBD, what are the forces acting on this? mg, normal reaction, the centrifugal force mv square by r. Friction will be which way? Downward, no? Because it is trying to go outside. So if you resolve these forces, we get friction, mg sine theta, mg cos theta, normal reaction, centrifugal force का भी component आएगा. This is where people will mess up. So be careful. mv square by r cos theta. So mv square by r sine theta. So the normal reaction is not mg cos theta. So we get n is equal to mg cos theta plus mv square by r sine theta. And here the centrifugal force component which is pulling it out will be mv square by r will be friction plus mg sine theta. Since it is maximum about to slip, we can write this as F max, which is mu into n. Which is mv square by r mu into mg cos theta. mv square by r sine theta plus mg sine theta. Bring all v's to one side and sine theta to the other side. You end up with v is equal to, so remember the speed is maximum, rg, it gets cancelled. Mu cos sine theta plus mu cos theta. This is mg square by cos theta. Cos theta minus mu sine theta per root. There, this is your maximum speed. If you go more than this, you'll skid outside. Now here they can ask you a thing like this. Condition for never slipping. That means Vmax should tend to infinity. That means the denominator cos theta minus mu sine theta should become negative or equal to 0. So from here we get cot theta should be greater than equal to mu. If cot theta is greater than equal to mu, this vehicle will never slip. Even if you go to infinite speed, it won't slip. That itself is a question. Find the condition on the banked road so that the vehicle never slips for any speed. Check this out. This is the maximum speed of the vehicle. So if you have a banked road which is rough also, the friction will become an extra factor there. Have a look at the steps. Now you can find the minimum speed also. What happens if you go too slow? Cos theta. I forgot. Yes. I wrote it here. नीचे इसलिए है, ठीक है. F max plus mg sin theta. You're right. Clear? Can you find the minimum speed? Try. I'll give you a minute. सिर्फ इतना difference होगा. Minimum speed with friction will be upward now. Solve. Use this as a reference. It is just solving brute force, nothing else. Try. I'll give you a minute and a half. Find the minimum speed. Everyone should try. वही होगा. Right, Anika. So this case, mg sin theta, mg cos theta, normal reaction, mv square by r cos theta. Most common mistake now, people write n is mj cos theta. Just be careful with that part. If you take care of that, rest of thing is fine. And friction will be upward this time. So we get normal reaction will be mg cos theta plus mv square by r sin theta. mg sine theta will be maximum friction plus mv square by r cos theta, and f max is equal to mu n. Bring all these to this way, you end up with rg sine theta minus mu cos theta mu sine theta plus cos theta. You could have removed cos theta outside, no? You'll get tan theta minus mu. In some books, you will see that also. Same thing. This is your minimum speed. So normally when you bank roads, na, you want the minimum speed to be 0. Why? Think about it. If minimum speed is not 0, if you stop the vehicle, it will skid. You don't want a road like that. So for me, minimum to be 0, sine theta minus mu cos theta should be less than 0. We'll get mu should be less than equal to tan theta. So your speed limit should be maximum, which is Rg. If I just remove that cos theta there, this would be tan theta plus mu 1 minus mu tan theta ka root, maximum speed. This is Rg tan theta minus mu tan theta plus 1. You can keep it in tan also. This is the minimum speed. As long as you go within this speed range, you're safe. Check this out. So this is like a question plus theory, everything. Exam, they might give you numbers, so you have to substitute, but this is how you solve. I don't want you to mug up the formula. Know how to do this thing. Right, Yash, Anusha, both of you got it. Have a look at this. Clear? Everyone got this thing? Any doubts? Anyone not favor the banking part? Please ask. Great. Let's see our question. So we have a marble racetrack. This thing, I heard a story. I don't know how true it is. In some country now, there is a, which one? Could you explain it? What? This only, right? See now, normally, did you see normally your speed should have been how much? Root over Rg tan theta, right? Aren't you getting little more speed now? If you go faster than that speed, banking speed, this one, which one? Root Rg tan theta. If you go faster than this, what will happen? Friction will come down. So you can go little faster. If you are going slower, the friction will go up. It can little slower. So instead of getting a one value, you're getting a range of values, right? So your banking speed 40. Even if you got 50, you won't skid. Because the friction will come and balance at extra 10 kilometers per speed. Clear? That's what I mean. The friction is the extra thing. So some engineer, right? They got an architect guy, some civil guy to construct a race car track. And what happened in this racetrack? They observed after finishing of the full racetrack, they observed no matter with what speed the vehicle goes, the time taken to complete the lap is same. Means you go slow or you go fast, the time taken for one lap is same. You're getting it now. On such a thing, how will you complete the race? Matlab, there will be no winner anytime. So we will take a scenario like this. So a marble racetrack, a smooth marble racetrack. It is observed. Let's call it right here on the better. It is observed the time taken a marble takes time t for any speed. The marble thrown with any speed. Meaning you take a marble, you throw it slower, this will go in a smaller circle. If you take a marble and throw it very fast, it will go in a bigger circle. Time taken is same. You're getting it doesn't matter with what speed you throw here. V2 is greater than V1. So if you throw with higher speed, you'll go in a bigger circle. Find the equation of the track. So I want you to find this equation. What is that curve equation? Exam options will be like y is equal to x square, y is equal to x cube, y is equal to root x, y is equal to x square, something of that sort. What is the equation of the track for such a thing to happen? Any ideas? These are the kind of questions you get in the exam. That's what I'm saying. You need to think. And these questions, even if you don't get right now, after class gets over today or tomorrow, maximum, take a rough paper and try them on your own. This is something I keep repeating every class, like a broken tape recorder. Understand why I'm saying that? So let's say this point is your origin. This point is x comma y. So let's say this guy is going in a circle here. So radius of the circle is x. So at this point, if you look at the forces, mg, the centrifugal force, and the normal reaction. So at this point, if you draw a tangent where there's an angle theta, there's one thing I can tell you in physics, at least 11th and 12th, whenever they ask you, find the equation of something, the idea, right, always is the only way you can do this is tan theta is dy by dx, slope from calculus, remember? Somehow, using physics, you have to get tan theta in terms of y and x, substitute here, and then you have to integrate. यही logic था, हर बार यही logic था. Somehow you have to find tan theta in terms of y and x. And this will keep coming up multiple times. You will see this in many places. Look at this thing. If you take a water and rotate it, you get a bowl shape, no? Idea was the same. You get a similar equations. Water cup bowl shape. When you put your hand in the water and rotate, no, you get this kind of shape. We will take later on also when you get an equation ka shape tan theta. So the shapes and all the stuff will be quite similar there. So the idea here is, so if you write the equation for this particle here, this n ka components will be how much? This guy is 90 minus theta. N sine theta. N cos theta. The centrifugal force will be m omega square r, and the weight is mg downward. So if you balance them here, n sine theta is m omega square, r is x here, and cos theta is mg. The radius of the circle is x. Divide them, you get tan theta is omega square x by g. But I also know tan theta is nothing but slope dy by dx. So you have to get tan theta from physics, and then the tan theta is dy by dx and finish it off. Omega square x by g, integrate, and dy is omega square x dx by g. Integral, you end up with y is equal to omega x square by 2g. This is a parabola. And what is omega here? Time period is 2 pi by omega. So omega is 2 pi by t. Angle by time will, angle by angular velocity will give you time period. You can put omega there and you'll get it. Check this out. So let the particle go at x comma y on a circle of radius x. Write the forces, get tan theta, and put tan theta dy by dx and integrate. So that civil engineer or architect, right, accidentally they constructed a parabolic track. So if you make a parabolic track, it doesn't matter how fast you go. Parabola will be along x-axis. Meaning, y is equal to x square, right? This is this parabola. That is x square is equal to y. Yeah, x is equal to y parabola. Clear with this, everyone? Easy one, if you see, easy to solve. But idea aayega nahi. So these are the questions, where they're little difficult to figure out, but they're easy to solve. So what is happening here is the faster you go, the bigger the circle you will take. So time will remain same. Clear? Next one. This we will do in gravitation also, but let's see, you will find this sometimes. Variation of gravity.
So can
You
you
could
go
take-
back to the menu?
Yeah, you're shouting suddenly, right? Why is your volume so high?
Yes, sir. Thank you.
His volume is high? No, I could hear it big again. Is there a way so that you go fast on a small circle? Then don't construct a parabola. If you construct a parabola, you don't have a choice. Don't construct a parabola. Maybe construct y is equal to x cube or something else. Next thing. Variation of acceleration due to gravity due to Earth's rotation. So if you take the planet, which is going with omega, and let's say we have a person standing here. This is the angle theta. Theta is called colatitude angle. Now, what is colatitude angle? Equator pe theta is 0. Theta is equal to 98 poles. So basically, it is that latitude angle. So if you look at the forces acting on this man, the weight will act towards the center. Remember, down is towards the center of the Earth. Since this guy is going in a circle, there will be a centrifugal force, which is m omega small r, and the normal reaction. And for this circle, this small r will be r cos theta, where r is the radius of the planet. So he is going in a smaller circle. So if you write the forces here, we get n is equal to mg minus, you can look at this component here. This would be m omega square r cos theta. Mg minus m omega square r cos theta, where small r is nothing but capital R cos theta, so m omega square r cos square theta. You can write this as m into g effective or g apparent. So people on the Earth, right, what we experience is not exactly gravity. Because of rotation, the gravity becomes slightly less, whose value is g omega square r square cos square theta. So this is the gravity we experience. So the exact gravity, right, you feel it at the North Poles. So normally when you launch rockets, it is preferable to launch near the equators, because the gravity value is little less. You need, less energy to make it go. So now if g apparent becomes 0 at the equator, they can ask a question like this. So question will be like, with what, to find omega so that the people at the equator will float. If g apparent is 0 at equator, this will be g minus omega square r theta will be 0 is 0. We get omega is equal to root g by r. So if we can make the planet rotate with this omega, people on the equator will literally start floating. We will not be touching the ground anymore. People at other places will, they'll be fine. Only people at equator will be floating. Because at other places that cos theta will not be equal to 1, it will be less so. Check this out. So this is how actually gravity is not same everywhere on the Earth. Even the rotation affects it. And second thing, Earth is not a perfect sphere. It looks more like a dented plastic ball type. But more about this thing we will study in a chapter called gravitation again. But for now, have this much idea there. And if you actually think about it, right, this is one of the biggest problem we have in going into outer space, gravity. Because human bodies, right, are designed to, we have evolved to be in gravity. So biggest problem we will face when we go into outer space. You guys have seen the movie WALL-E?
Yes, sir.
WALL-E, that robot go movie.
Yes.
In that movie, if you see, there is this scene, these people have gone into the outer space and this thing goes up. If you observe the people in that movie, right, all have become pretty fat. They can't even walk also. They all are transported everywhere on some space vehicles inside. Did you guys remember that scene? That's what actually happens to humans. The problem is, for astronauts who go into outer space, every day they exercise for 4 hours. just to maintain a normal shape. That is because on Earth, now, even though you don't do an exercise, when you're walking or when you're sitting or standing, the gravity is always pulling you down. So the body maintains a certain muscle mass in order to sustain gravity. Getting it? But if you think about it, right, body ka muscle, right, is pretty difficult or pretty expensive to maintain for the body. Did you ever see these bodybuilders who go for gym competitions, big body and everything? If you see the same guy after 1 month or 2 months, you won't even recognize him. Pata hai? After that competition gets over, these people will eat like a normal person. The muscle will start just goes off. Muscle just goes off. They become you won't get so much body ka muscle because maintaining so much muscle mass on the body requires a lot of energy, and it is evolutionary wise doesn't make sense. So body will simply just remove all that muscle from the body. If you stop working out for 3-4 months, all that muscle goes off. Within 6 months, they look like a normal person again. वो steroid अलग story है, but you're getting it. So now what happens if you're in outer space? There is no need for muscle to be maintained, right? Because body will think maintaining muscles will take so much energy. Why should I put so much effort? You get the point? So what will happen is once you're in outer space, your body ka muscle content will start decreasing, right? And you become more like a fat. Whatever you're eating will all go into fat only. So and you lose the ability to walk also properly. That's why when people come from this outer space, right, who are there in outer space for 6-7 months, when they come back to the Earth, they have to be dragged out of the spaceship. They can't even walk also. It will take them a month or so to get adjusted. So the biggest problem we will face when we go into outer space is no gravity. So how do you get gravity in space? We don't know how to create gravity. Okay, that's the first thing. Did you guys see Interstellar movie?
Yes.
The full movie ka story yahi hai. How to manipulate gravity so that we can take this spaceship into the outer space. The spaceship is so big, we don't have any rockets or any fuel that can pull it out into the gravity, into the space. So these people try to figure out a way to tweak the gravitation, blah blah blah, whatever is the story. And that is the whole thing. Like, so they say you get some information about that variables inside a black hole, and that's what the hero sends the signal, and his daughter actually completes the theory, and these people do something and they go into outer space. If you actually think about it, that was a whole story about it. So how do we survive then? If you go into outer space tomorrow, if humans have to go into outer space, travel very far, how do we survive? The idea, right, first time I saw the idea came from Tom and Jerry. Tom and Jerry ka thing, I have seen this in that one scene, na kuch episode tha, it was like Space Cat and Space Jerry karke. So there is a round kind of ship. So Tom is like a space cat and Jerry is stealing cheese in the spaceship also. Story the same hai har baar. Just this time it is in outer space. So it is like a round disc, okay? It's like a round disc here and it is rotating with omega, something of this sort. So what is the idea behind it? I'll tell you. See, you have to construct a big cylinder. Your spaceship should be like a cylinder. And you rotate the cylinder with omega. Now see what happens. When you're standing here, the centrifugal force will pull you down, that is away from the center. So if you can rotate the cylinder such that if m omega square r becomes equal to mg, so the people standing here will think what? You are being pulled away from the center. That will behave like gravity. Are you getting it? So on this spaceship, you know how things will be? The buildings will be like this. So in this world, what is up? Up is towards the center, away is away from the center. Down is away from center. So meaning if I stand here, you will stand like this here. We can say hi to each other, like you're seeing from the top and I'm from the bottom. You're getting it? This entire world will be like a circular kind of thing. So this is how, if you go into outer space, we can work this out. If you have seen Interstellar, you will realize this.
Mr. Cooper.
You don't have the volume?
It's easy, Mr. Cooper. Remember, you're no spring chicken anymore. Actually, you are 124 years old. The rain.
Something happened to the audio. Okay, that's not important, but see.
extremely lucky. The Rangers found you with only minutes left in your oxygen supply.
Look at this scene, huh? Kids are playing cricket, baseball. This guy hits. Can you see how the world is? This is the Interstellar climax. If you see, these people actually go into the outer space finally, they build a world which is cylinder. You can see how that world is curved. See how it goes. Can you see how the houses are? This is what I was saying, up and down ka concept. They live in actually a rotating cylinder.
Cooper Station.
They call it a Cooper station. Yeah.
Orbiting Saturn. Cooper Station. You, sir, and a couple were
Situation. I was delighted to hear that she thought.
ऑडियो नहीं आ रहा अच्छे से, ठीक है. Are you clear with this? So if humans go into outer space and you want to live in there like a colony, we don't have an option but to create a rotating cylinder, which is root g by r. So, or else we won't be able to create gravity. We will start dying very soon. We will not be able to, sustain only. We have a lot of health issues. First health issue will be like, you become anemic. Your body will stop producing RBC properly. Because if you see now, your arteries and veins in your legs are thinner compared to arteries and veins in the upper body. So what happens because of this? Ever seen with this thing, water ka pipe? If you close the water pipe, speed increases. If you put your thumb on the water, it increases. Meaning smaller pipes have higher velocity. So the blood flows from the legs to the upper part of the body with high speed. On Earth, what happens? Because of gravity, it again goes down. But space mein kya hoga? The blood will start accumulating in the head. And the brain starts thinking we are producing too much RBC. So it stops producing RBC. You start becoming anemic. So we get all kind of health issues. Clear with this? Next thing. Non-uniform circular motion. So in the Tom and Jerry video, now it happens like that only. The entire spaceship is rotating in circle. It's not exactly the same thing, but I remember the first time that this whole thing is rotating. The Tom and the Jerry are running around, and the best part I'll tell you, the Tom takes a gun and starts shooting everywhere. The entire spaceship becomes holes. So pura air leak ho jayega. So the human master will come catch the Tom and beat it right and left, and they send Tom outside. The Tom puts the gas cylinder and starts pumping air into the spaceship. And best part is vacuum. Where will you get the air from? So, but that it was fun. So actually, the Tom takes the Jerry and puts in a spaceship and throws it off. And Tom is happy like, oh, ye bhag gaya karke. So this Jerry goes and lands on a cheese planet where it is full of made of cheese. So it sits there and starts eating. So that's funny, but yeah. Non-uniform circular motion. So till now we have seen uniform. Let's see what is non-uniform. Next thing. So what happens in non-uniform circular motion? The velocity is not constant. So the speed of the particle is not constant. So therefore, the particle will have two accelerations. The particle has centripetal acceleration which is responsible for making it go in a circle. If you want to go in a circle with speed v, you need to have a centripetal acceleration. This we proved in the beginning. Responsible for making it go in a circle. And there'll be also tangential, that is basically direction changes. The centripetal acceleration changes direction. And now we have a second acceleration called tangential acceleration, which is responsible for changing speed. So the only new thing is you have an additional acceleration now. So this A tangential is nothing but will be dv tangential by dt or v tangential dv tangential by ds. S here is the arc length or the distance traveled along the circle. Distance along the circle. So whenever this guy is going in a circle at any instant, it will have a centripetal and it will also have a tangential. The resultant is the A net acceleration. If someone asks you find the acceleration of a particle going in a circle, remember it has two accelerations. Till now we ignored the A tangential. So A net will be AT square plus A centripetal square. Have a look at this. And one more thing, this A tangential can be also written as R alpha. We have done this in the beginning. Alpha is your angular acceleration. Let me show you one example how they'll frame questions on this, and I'll ask you more. Have a look at this page. Clear? Let me show you a problem. So consider a vehicle starting from rest. Goes in a circle of radius r. With constant tangential acceleration. So the question would be like, find speed, A centripetal, A net, frictional force and time when it slips. Now I can ask you anything. So let me show you how this works. So when this guy is going in a circle, so let the mass be m, initial speed is 0. You're going with an acceleration at, which is equal to a. Since the acceleration is constant, we can use the formula v is equal to u plus at. We get v is equal to at. This is the speed. A centripetal will be v square by r, which is a square t square by r. Net acceleration will be root over a centripetal plus a tangential square. Yeah. So this is how you get the a net acceleration. But let me show you on a bigger diagram. Are you guys getting any disturbance from my side? Yeah. And outside people are that I think Ganpati ka wo Visarjan hai na, first day I guess. Luckily my headphones are noise cancelling. I think that's why you guys can't hear. I can't even hear my own voice now. इतना आवाज आ रहा है बाहर. Play with this. So let me show it in more detail how this thing looks actually. When this guy is going in a circle and you're here, you have only a tangential. So when the block comes here, we have a centripetal and we have a tangential. Now understand a tangential is constant, that does not change. Whereas a centripetal is increasing, it is becoming bigger and bigger. You're getting how is the acceleration changing? So the resultant would look like this. This is a net. This is a net. There. If you see the acceleration is not constant, it is always changing direction and it is not towards center. So in this case, we observe that a net, so a centripetal keeps increasing. Because what is a centripetal? V square by r, and v is increasing with time. Therefore, a net will increase. Is getting closer to center. It is getting closer to the center, but it is not going towards the center. Now tell me one thing, who is providing this net acceleration? The one to provide this net acceleration is friction. There is no one else. So friction should be equal to m into a net. And what is a net? Root over a centripetal square plus a tangential square. This guy would be v square by r the whole square plus a square, which is less than equal to mu mg. Mm cancels and will be a power 4, u power 4 plus a square is less than equal to mu square g square. We get time is less than equal to up to this time it is safe. It's after this time. Check this out. There we got everything, right? We got friction, speed, centripetal time, सब आ गया. So normally what used to happen when you're going in a circle, the friction used to provide that centripetal acceleration. So here, the friction is also providing tangential and centripetal both. So that's why the friction won't be, towards the center. Friction will be at an angle now. Yeah. Yeah. You guys can't hear anything, right, from my background? You should see how much sound it does. Headphones are working properly then. Okay. Then I will just show you more here. If you consider this angle to be theta, we get tan theta will be a centripetal by a tangential. Theta is the angle between the velocity and the net. Yeah. Let's see a question. Same thing. So we have a vehicle, mass m. Has an acceleration at. At is equal to time. Radius is 10 meters. Let's say mass is 2 kg. A vehicle goes in a circle with tangential acceleration A is equal to T. Starting from rest. Find velocity, find speed. Distance traveled. A net. Friction. Angle between velocity and the A net as function of time t. So let's finish off this. Same question, I just changed it. Instead of giving constant, I gave a this thing. Finish off last one to that. Next class will wrap up the chapter. We'll do more problems on this. And then let's see if time permits, we start work for energy introduction. Try everyone. Just give it a try with some water. Let's see. 5t cube कैसा है यानी का? Speed ठीक है. Speed v square by 2 or t square by 2? Integration everyone. Try. For me, na, in Andhra Ganpati festival, मतलब one day we are done. For you guys, it's a big festival here, na? I know my wife does this. I mean, she's also planning to start puja in another 5 minutes. She's waiting for our class to get over. तो होता है हमारे घर में ऐसा. So I'm from Andhra, so she's from Mumbai, so she doesn't understand. I don't understand what she's doing. She doesn't understand what I'm doing. Andhra में our major festivals are what? Dasara and Sankranti. For us, Diwali is like one day. That's it's not a big deal for us. Ganpati is like one day. It's all reverse. How do we do this thing? First one is what? L is equal to T. Integrate this. Integrate. Integrate again. Don't write x, write as s, okay? Because it's a tangential velocity, the tangential distance. This guy would be t cube by 6. Anika, did you do 3 into 2, 5? मुझे 5 कहाँ से आया रे? t cube by 6. हाँ. A centripetal. V square by r. V is t square. So t power 4 by 4r. A net will be root over a centripetal square plus a tangential square. So that would be t power 8 by 16 r square plus a will be again t square. Friction will be mass into a net. और क्या चाहिए? Angle ना? This will be a tangential. This will be a centripetal. This is angle theta. And theta will be a centripetal by a tangential. A centripetal is t power 4 by 4r by t. T cube by 4r. That's your angle. Check. Yeah, 40. That's it. Like I said, now it is really not that different. It mostly like kinematics only. Non-uniform circular motion, every time the tangential keeps popping up. Check this out. Any doubts on this, please ask. Yeah. Okay, with that, we'll wrap up for the day. I'm unable to bear this sound.